So now we're going to solve a system of inequalities. So what you see on the board here, we're supposed to solve the system that says the y values are less than or equal to negative 2x plus 3. The y values are greater than or equal to x, and x is always greater than negative 1. So what I would recommend for solving this system is to use a graph because there's a lot going on here. First of all, if x is greater than negative 1, that means here's x equals negative 1. I call that a boundary line. So the first thing I do is I graph the boundary line. And then I decide which side gets shaded. Now in this case, it's pretty easy to see which side gets shaded because it's the numbers greater than negative 1. So here's the whole boundary line of x equals negative 1, and these are all of the values greater than negative 1. Okay, I'm also supposed to be graphing y is greater than or equal to x. So the boundary line there is going to be y equals x, which is this line right here. Oh, and since it's greater than or equal to, I can actually make that a solid line that goes through all of those. So that's the boundary line y equals x. And now I'm going to look at which side to shade. It says y is greater than or equal to x. Some of you might know right away that that would be on top of the line. But if you don't, just pick a point in either spot. So I'm going to pick a point here at negative 3, positive 4. And I'm going to test it and see if it's true. So when x is negative 3 and y is positive 4, is that a true statement? And the answer is yes. 4 is greater than or equal to negative 3. It's actually greater than. So everything up here is going to get shaded. Okay, the last one, y is less than or equal to negative 2x plus 3. Y is less than or equal to negative 2x plus 3. The boundary line is y equals negative 2x plus 3. And that line I graph by starting at 3 and then going down 2 over 1. Down 2 over 1. I can do that as many times as I want, or I can just draw a line that goes through all of them. And again, it's less than or equal to, so I'm going to make that a solid line. Now I'm going to pick a test point of 0, 0 and see if that works in my original statement. Is 0 less than or equal to negative 2 times 0 plus 3? And let's see if that's true. Is 0 less than or equal to 0 plus 3? Yes, it is. 0 is less than 3. So I'm going to shade that side with the 0, 0 on it. Now what I'm looking for is I'm looking for where all three things got shaded. So I see black shading, I see blue shading, and I see red shading. So that is probably going to be in this little triangular area right here, where all three things have been shaded. Now the way to double check that is I'm going to pick a point in that shading. So see this point here at 0, 1 is kind of in the middle of all that shading. And I'm going to test it for all three of these inequalities and see if it works. So when y is 1, x is 0. And let's just see if that works. So is 1 less than or equal to 0 plus 3? Yes, it works in that one. Is 1 greater than or equal to 0? Yep, that's true too. And is 0 greater than negative 1? Yes, it is. So it works in all three, so I can be fairly confident with that answer. I might want to try testing a couple more, but I'm pretty confident.